Alright, so this is a related rates problem. Water is being pumped into a conical trough with a top radius of 2 meters and a height of 4 meters. When the water level is 1 meter, the rate of change of the water level is 1 meter per second. At what rate is the water being pumped into the tank? Well, first, you might want to draw a picture. So, this is a cone. The top radius is 2 meters and the height is 4 meters. And then the next thing you need to do is decide, what equation am I really working with? So I would like to figure out the rate water is being pumped into the tank. So what that makes me think is I want to work with the volume of water equation. Now, the volume of water equation, to get that, we might want to draw what the water might look like. So if you draw just a random water level in there, the water is just going to be a cone. So I want to work with the equation for the volume of a cone. So that's going to be the volume of a cone, where H is the water level and R is the radius of like the top of the water. So that's great, but I would really only like to have two variables before I start my calculus. So I need to do something clever to get rid of R or H. And from the problem, they told me about the rate of change of the water level, which is what we call H. So I want to get rid of R and keep H around, because I know things about H, but I don't know anything about R. So the way I'm going to do that is I'm going to take this picture and draw it a little different. I'm going to come over here. That's 2 meters. That's 4 meters. If I draw a random water level, that's R, and that's H, and what I have here are similar triangles. So what I can say is that 2 over 4 should be the same as R over H, or R is 1/2 H. Now I can come over here, and I know R in terms of H, so I can plug it in. So volume is 1/3 pi 1/2 H squared H, or 1/12 pi H cubed. So now, I haven't done any calculus yet, but I've successfully eliminated R as a variable. So now I just have V and H. So I can take a derivative, but I'm taking a time derivative. So it's kind of an implicit problem. So the derivative, dv dt, is going to be 1/12 pi. Then this derivative, just like you'd think, but since h is a function of t, I pick up a dh dt. Now I ask, do I know things? And I go back to the problem. When h is 1, or when the water level is 1, I get that. And the rate of change of the water level is also 1. So I know dH dt is 1. So I plug all that in, 1 here, and I'm just left with 3 pi over 12. So the water is being pumped in at a rate 3 pi over 12. And you can supply the units, so this is volume per time. So the units would be like meters cubed per second. And that's that one.